We're going to deal with the logic expressions. So to understand the logic expressions, we are going to use the gates, the logic gates. But before that, we need to make sure that we know that the logic expressions can be derived from two situations. The first is the logic circuit, and the second is from a truth table. So you can get the logic expressions out of any of these. So to start with, we are going to use the logic circuits, and we're going to take an example over here. So let's assume for the logic circuit, we have got three variables. So let's say it's A, B, and C. Between A and B, we have got OR gate. From C, let's take a NOT gate. And let's assume these are joined together with AND gate. That gives you an output X. So now if you look at this whole circuit closely, there are three gates. There's one gate over here, then there's a second gate over here, and then there's a third one over here. Let's write them individually. So one gives you A or B. Remember, the logic gate has to be written in uppercase. The second is just the AND, which is combining all other gates. The third is not C. To put the logic expression together, we need to combine these. So it becomes, and we always start with X. I'm taking another color to make it very clear. X is equal to A or B. Since it's combined with one gate, we are going to put them all together in one bracket and not C. So this is the logic expression. The same logic expression can be written in Boolean algebraic form. Let's do that as well. So it becomes X is equal to A. The OR is replaced with plus. So A plus B. Then there is a dot and there is a not C. So C with a bar on the top. So this becomes the logic expression from the logic circuit. Okay, let's take one more example, example 2, and understand the derivation of a logic expression from a logic circuit. So we are going to take three variables again. So three variables A, B, C. So let's draw the logic circuit first. So let's say we have got A, B joined together with not AND gate. Let's try a different gate this time. Let's take a not AND gate. Remember, AND with the circle in the front. So this is to be joined further. Let's take from B NOT gate and join these two together using exclusive OR gate. Remember, the bar cuts over the line and then you have got the OR gate. And then let's take one more variable, as we are interested in three variables C. Join these together using AND gate again. That gives us an output X. So if we look into this circuit, we have got how many logic gates? So this is going to be 1. Then we have got 2. We have got 3. And then there's another one, that's 4. So let's put these together. So one gives you A, not AND, NAND, B. Second is exclusive OR gate, that's combining it with B not. So the third is not B. And then we have got the fourth one, that's AND gate. So let's just put this together. Now to put the logic expression together, we need to combine all these gates together. So logic expression becomes X is equal to, we are going to be very careful with this whole thing about brackets, because if you look at the circuit diagram, this is one whole set or part 1 which is combined with the second one. So accordingly you have to put the brackets later on. So this is one and then this is combined with the second one. So there are two parts to it. So we'll put the brackets accordingly. So this whole expression becomes X is equal to A NAND B XOR, exclusive OR. It's not B. Since this is part 1, we'll put this all together in one bracket and combine it with AND C. Let's try and put this into a Boolean algebraic expression as well. Boolean algebra. So X is equal to, look at it, A NAND. So it's AND gate. So AND is represented by the dot, A and B and the complement of the two. So this, the XOR gate is represented by plus inside the circle, not B. The not B is represented by the complement on the top. So this is all together in one bracket and dot C. I hope it's clear now. We are going to look at the logic expression to be derived from a truth table. So let's take an example. So example 1, and we need to draw a truth table. So let's take it for the two variables, A, B. So two columns and one for the output. So the first topmost row is for the variables A, B and X. Since we have got two variables, there will be 4 rows. 1, 2, 3 and let's add one more, 4. Standard way of entering the input values: 1 time repetition 0 1, 2 times repetition 0 0 and 1 1. Let's assume that we have got 0 1 as the output, 2 zeros over here. So how do we start combining this? So I'm going to use a different color to make sure you understand it clearly. The first and very important hint is we need to consider the value, or rather the row where the output is 1. So this is the first hint. Consider the row with an output as 1. That's the first thing. The second important hint is combine the variables in this row using AND gate. So now let's try and write the expression together. We have got, if you look at the first, A is not A, and then we have got B because B is equal to 1. So X is equal to not A and B. Since it's one expression, we have to put it in a bracket. Take one more example to derive a logic expression from a given truth table. Again, we are going to use two variables but with a different output. The two variables I'm going to use is A, B. So let's get the inputs together. Two variables means two columns. We're going to take one for the output. This row is for the variables A, B, X, and then we have got 4 rows. 1, 2, 3 and 4. The inputs 0, 1, 0, 1. For now I'm using these standard inputs. So yeah, let's take the output a little bit more than before. So 0, 1, 0, 1. Now quickly changing the color to emphasize, we have to use the rows with the output as 1. So we have got this row and this row. Remember, we need to combine the variables in between using the AND gate. So let's go ahead with this row. So this will give you A is 0, so it's not A and B because B is equal to 1. This row simply gives you A and B. To put the logic expression together, we need to combine these two expressions together, and then it becomes something like X is equal to not A and B. Since it's a separate row, we put it into a bracket, and this is to be combined using the OR gate. So the second row, A and B. So the outcome is two things. First is, the first rule is consider the rows where the output is 1. That's the first rule. The second, combine the variables in this row using AND gate. Let me underline this. And the last rule is combine these rows using OR gate. Let's take one more example where we are going to use three variables ABC in the truth table to derive the logic expression. So let's make the truth table first. Since it's three variables, we'll need the 8 rows and 3 columns, 2, 3 and 1 for the output. The topmost row is going to be for the variables. It'll be A, B, C, X is the output, and let's make the 8 rows. 1, 2, 3, 4, 5, 6, 7 and 8. Let's enter the values. 1 time repetition starting with 0 followed by 1. Complete all the entries in all the rows. Now it's going to be 2 time repetition. A is 2 to the power 2, so it's 4 times. And this completes the input. Now let's assume the output is something like 0, 1, all zeros, and let's take 2 more as 1. Now, to put the expression together, we need to consider the rows with the output as 1. So it's going to be this, it's going to be this, and this row together. So let's write the expressions individually. A is 0, so it's not A. Remember, we have to combine the variables within the row using AND. So it's AND, not B, and C. That's our first expression. Let's get on to the next. This is A and B and not C. Another row. This is A and B and C. Now to get the output X, let's combine them together. So X is equal to not A and not B and C, using the hint that we need to combine different rows using OR. So it becomes OR. The second expression in another bracket, A and B and not C, or the third expression, which is A and B and C. This seems to be a longer expression which could be definitely simplified, but for now let's keep up with this. The topic for now is trying to represent the logic expression. So basically, if you recall, we could convert these logic expressions into a logic circuit or truth table. So there are 2 ways of representing it, using the logic circuit, or the second is using the truth table. Let's try to explore these further using the example. So example 1. Let's take a logic expression. Z is equal to R and S, or R and T. Let's use the first method, logic circuit. If you monitor it closely, you will see there are 3 gates. This is the first, then we have got the second, and then these are combined together to get the third gate. Use the BODMAS and it will be easy for you to understand, because you need to solve the brackets first and then combine them together. So let's get started with the logic circuit. What are the important things to note here? First is there are 3 inputs. 3 inputs. The output is represented by Z, and the logic gates used are AND, OR. And most importantly, how many gates we have is altogether 3 logic gates. So this should be giving you the overall picture of how it should be working. Now let's draw the logic circuit. As we started, 3 inputs. So let's go ahead. Do the first one. We'll follow the first R, S. Between the two, there is an AND gate. And let's leave for the output. Next, we are going to deal with the second logic gate, which is between R and T. Whenever you want to use R again, you can bring down the input here. And of course, T is going to be starting fresh. So we have got R and T, another AND gate. Now the third is OR gate between gate number 1 and gate number 2. This gives you an output Z. We'll use the second method, truth table, to represent this logic expression. So for the truth table, we need to decide upon the number of rows and columns. Since we are having 3 variables, the rows are equal to 2 to the power 3, which gives us 8 rows. And the columns remain equal to the number of variables, that is 3 columns. So now let's make the little structure. We'll make the 3 columns for the input values first. 1, 2, and 3. And we'll be adding more columns as needed. So let's make the rows first. The first row is dedicated to the variables, and let's have the 8 rows. 1, 2, 3, 4, 5, 6, 7, and 8. Let's take the input values for R, S, T. T is going to be one-time repetition. So let's fill the input values. And you need to complete all the rows. S is 2-time repetition. And R is 4 times. So 4 zeros and 4 ones. Now let's write the details for the expression. So we are going to start with 1. 1 is equal to R and S. So we are going to deal with R and S together. Remember, the AND is all about multiplication. So multiply the two. 0, 0, 0 and 0. 1 and 0 will give you 0. 1 and 0 gives you 1. Sorry, 0. 1, 1 gives you 1 and 1. Now let's take the second expression, which is R and T. Be very particular about the columns you are taking so that there's no confusion. So let's multiply again. So straightforward, R has got 4 zeros. So anything multiplied will get you 4 zeros. And then we need to look into this. T is 0, so it's 0. Both are 1, so it's 1. T is 0, so 0. Both are 1, so we get 1. Now we need to use number 3. So to write number 3, we could just use these expressions or 1 and 2, which means 1 or 2. So let's get these two. Remember, this is OR. That means you need to add the 2. So 0, 0, 0, 0, 0. 0 plus 1 is 1. 1 plus 0 is 1. And then we have got 1 plus 1, 1. You must be wondering why 1 plus 1 is 1. It's all about the binary. It says if this is true and this is also true, the output is going to be true. So this is the truth table representing the expression which we have already completed in logic circuit before. Take another example, example 2, which is a logic expression, and we are going to convert this into a logic circuit. So let's decide the number of gates. This is going to be the first. Use the BODMAS rule and it will be much easier. Number 2, we need to solve this bracket first. So this becomes 3. Then we have got another gate over here, 4. 3 and 4 together will give us the fifth gate. So one thing is clear, we need to have 5 gates in the logic circuit. So let me put it together, logic circuit. Now let's take the inputs one at a time. So we'll start with AB. So this is going to be my A and this is my B. So the first gate, A, B, is giving me AND gate. Now we need a knot of C. So I'm going to use the C here. Remember, knot is the triangle with the circle in between. Let's give the output, and then these are both connected using the OR gate. Now let's get for the fourth gate, which is B nor C. We can take the input from B straight from here. It's important to see NOR. You cannot take it from after the NOT. You have to take it from before, else it will go wrong. Between the two, it's a NOR gate. So another OR with the circle in front. Now the fifth gate is the exclusive OR. So we combine them together. Remember, the curve is crossing the two lines, and then we have got the OR gate, which gives us the output X. This represents the logic circuit for this particular expression.